So we'll start now. So today we are going to perform this experiment, temperature control system. Okay, so we have this kit, so in which we are going to control the temperature of an oven. This is our oven. Okay. The oven, we have to control the temperature of this one. So we have this setup. Okay. So in this setup, so we have this oven. It can go up to this 90 degrees Celsius, and we have this post cooling option. I'll show you, and we have different type of control action. So mainly we are going to perform 4 type of control action. Okay. So you have a sensor which will sense the temperature. So it is a set temperature sensor. So we are going to control the temperature by using 4 different mode of control action. So first one is this relay controller. We can say normally it is a on off control. Okay. So you can see here in this diagram is P, I, D and R, and this is our reference point. So we'll set the reference temperature. Then what is our temperature requirement? So we have this P, I, D and R. So R is known as relay controller, or you can say normal, it's on-off controller. So you know P is the proportional controller, I is the integral, and D is the derivative controller. And we have this driver, so it is actually an actuator, okay, which will drive the oven to either heat or cool down. We have this option, this cool, okay, this cool, off and heat. So cool means this is forced cooling, and when we switch select this switch to this heating position, at that time our oven will start heating. So now this wire is connected to our oven. So we have a reset button here and a pause and run button. So this on button is for to switch on this instrument or this kit. So here in this panel we'll see the temperature and how the temperature is changing in Celsius, and similarly timer. So according to time, what will be the change in temperature? So because this will be a time response analysis, right? So as time goes on increasing, what is the change in temperature? So we have these 3 knobs. So by changing this knob, we can by varying this knob, we can adjust this parameter of P, I and D. So this is the gain value, right? The Kp, the proportional gain, the integral gain and the derivative gain. So we can only adjust from 0 to 1. So all of this P, I and D. We can change the gain value Kp, K and Kd up to 1. So here from this oven, right, this is a feedback path, right? This is a feedback path, and we are using a negative feedback system. You can see here we have a negative symbol, right, in this summing point. So you are using a negative feedback path. We are using a negative feedback path. Okay. So this is a negative feedback system. So that means the temperature, the output temperature will be subtracted with this our reference or set temperature. So this sensor is our this solid state temperature sensor. Okay, so I think all of you know about solid state temperature. So it is normally PN junction. The solid state temperature is a normal PN junction. We could have used the thermocouple, but it output range it up to some millivolt. So we are using a solid state temperature sensor. So first we have to here it is hysteresis. Okay, so we are going to do in the low hysteresis mode, because in case of high, if we select high hysteresis mode, that means the hysteresis curve will have a very wide gap. So that will take more number of readings. So we are going to put this kit into low hysteresis mode. So here we can see a knob is here, right? In upper it is set and below it is measure. So set means when we select this switch towards set, that means at that time we are going to set the temperature. We can say we are setting our reference temperature. Okay. Then measure. Measure means then at the time the temperature will change according to our set point. So this will be a closed loop system. Okay, so this is a negative closed loop system. So let me just show how the graph, the output graph, if you plot the time versus temperature, how the graph will be. So in the x-axis we will take time, and in this axis we will take temperature. So suppose we are taking our reference temperature as 60 degree Celsius. Okay, just in case of suppose let's take for example is AC, and we are taking our set temperature as 24 degree Celsius. Okay, in case of AC. So suppose it is very cold outside. Okay, so we have our room temperature as 10 degree. We have our room temperature 10 degree Celsius. So when we switch on the AC, then that means at that time, or this heater at that time, it will go up increasing like this, like, and it may go up to go beyond this 24 degree Celsius, right? And then it will calm down again. So why it will calm down again? Because we are using a negative feedback system. Negative feedback means in this case, suppose we are setting giving our reference temperature as 24 degree Celsius. So this means this is a feedback path, so output is 24 degree Celsius. So at that time, suppose our initial temperature is 10 degree Celsius. Okay, so at that time a negative feedback path will go, and it will give this is 24 and this is 10. So that means we have another 14 degree to adjust, right? The output of this summing point will be 14 degree, right? So this 14 degree will be adjusted by this driver. Since this driver or actuator, it will give signal to this oven so that it will increase the temperature to 24 degree. So it may go beyond 24 degree, it may be 25 or 26, right? So it may be 25 or 26. So at that time, our sensor will again sense that the temperature is now 25 degree, but our requirement is 24 degree, right? 25. So that means there is a 1 degree difference. So now this error is -1. The output of the summing point is the error. So now it is -1. So now again this driver will, or this controller will, it provide the signal to this driver, and this driver will try to bring down the temperature to 24 degree. So it may again go down below 24 degree. So it will carry on like this one. The temperature will oscillate, right? This temperature will oscillate about this 24 degree Celsius. So
sir, sir 10 or 24 degree टा टिके आउतरे बुझी परिवे.
आमे को नेगेटिव फीडबैक सिस्टम देइछे एठी, राइट?
Yes sir.
So output is now about 10 degree Celsius, right? But our requirement is 24. So now this sensor, this temperature sensor will sense that the output is 10 degree. So it will give feedback to this summing point, right? So now what is the error? The error will be 14 degree, right? Plus 14 degree. So now this error will be given to the driver for our normal closed loop system, okay? So this driver or actuator, now it will drive this oven, right? It will drive that oven that the temperature is below our set point. So it will try to heat the oven again. The driver will heat the oven up to the 24 degree Celsius. So it may go beyond 24 degree also, okay? जब इसका heat करी चली जी, तो maybe 25, 26 जाई पाए. So at that time पुनी कौन होगा? Sensor आउथरे gain करी, sensor आउथरे sense करीबो, जब temperature टा set point to 2 degree अधिका पड़ेगी. अगर पुनी से command दबो driver को, driver ता कौन करीबो? Automatic oven को बंद कर दबो, right? Oven को automatic बंद कर देले कौन होबो? टेम्परेचर पुनी खसिबो धीरे धीरे. तापरे जेतेले पुनी कमी जीवो आउथरे 24 तळको पळे आसी मतलब कोळी आसी गेला टेम्परेचर. तापरे सेंसर आउथरे सेंस करके ड्राइवर को आउथरे सिग्नल दबो. तापरे ए ड्राइवरटा ओवन को आउथरे ऑन करियो. क्लियर? तो से मेंटेन करियो सब बेले 24 डिग्री पाखा पाखी रखिया पे. एग्जैक्ट भी रही पारे और अराउंड दिस 24 डिग्री सेल्सियस इट विल ओसिलेट. क्लियर?
Yes sir. Sir आउटी से PID पार्ट टा.
अब PID पार्ट में जाउ छेला.
Yes, sir.
फास्ट हम रिले कंट्रोल रे एटा एमपी ग्राफ आसीयो हला ओसिलेट हबो हम देखिया सेटा तो रिले कंट्रोल माने कोन नॉर्मल क्लोज लूप कंट्रोल ओके हम सीधा क्लोज लूप कंट्रोल देइछि तो तापर हम पी आई और डी देखि देखिबा हमर कोन चेंज आछि हमर टेंपरेचर आउटपुट रे एक केसे कोन हमर ओसिलेट होउछि हमको ओसिलेशन दरकार नै हमको कांस्टेंट 24 डिग्री दरकार राइट हमर ग्राफ केमति दरकार टिके उठुठ हे चलिबो किंतु ग्राफटा हमर एमदी कांस्टेंट 24 डिग्री रहिया कथा स्टार्टिंग रे मे बी अधिका जाई पारे बट we want that our room temperature should always stay in 24 degree Celsius सेति पे हमें कोन करबा कंट्रोलर दबा पीआईडी कंट्रोलर ओके एना नॉर्मल हमरो क्लोज लूप करले टेंपरेचर टा ओसिलेट होची तो सेही टाइम रे हमरो जो हीटिंग सिस्टम की कूलिंग सिस्टम अछि तावर बेसी इफेक्ट पड़िबो सबले से ऑन ऑफ हबो सेति पे हमें कंट्रोलर दबा ओके सेति पे हमें कोन अछि एतिरे तीनटा अछि पी आई और डी तो पी रो कोन हमरो ट्रांसफर फंक्शन कोन केपी पीआईडी वाला केपी इंटू के आई बाय एस इंटू केडी इंटू एस राइट तो हमें जो 1 बाय एस और एस को तो चेंज करि परिबानी तो हमें केपी के आई और केडी को वेरी करे जेटा हेला हमरो गेन तो केपी टा प्रोपोर्शनल गेन এই কেস না জাস্ট এটা পিআইডি কন্ট্রোল কেপি প্লাস কেআই বাই এস ইনটু কেডি এস तो 1 by s कोन इंटीग्रेटर और वी कैन से पोल एट द ओरिजिन सिमिलरली kd into s माने पोल सो 0 एट द ओरिजिन तो हम याकू चेंज करबे s र वैल्यू को वी कैन ओनली चेंज दिस kp ki and kd value because these are gain value right they are gain value so these gain value can be modified by these three knobs so this is for kp this is for ki and this is for kd so we have only option to modify this gain to 0 to 1 right 0 to 1 0 to 1 so first we'll go for this t controller okay that means we have to remove this relay control and then first we have to check what will happen if we only give the proportional controller then similarly we will go for pi controller proportional and integral controller similarly d controller then PID controller we will give then PID so what is the effect of p proportional controller on time response anyone or PID experiment is sir ji और ट्रांजिएंट रेस्पॉन्स रे प्रोपोर्शनल कंट्रोल इफेक्ट है कोन कोटा चेंज को पार्ट चेंज हबो सो प्रोपोर्शनल कंट्रोल देले हम सिस्टम टा फास्ट हबो हला यदि हम प्रोपोर्शनल कंट्रोलर दबा सिस्टम टा फास्ट हबो सो माने कर एई केस रे कोन एई केस रे हम राइज टाइम टा एई केस रे आछे एई पॉइंट रे प्रोपोर्शनल कंट्रोल को ठीक से ट्यून करिबा देन हमर राइज टाइम टा हमर ग्राफ टा सीधा एमपी भी हेई पारे हला ए भलिया भी हेई पारे त सिस्टम टा को हम फास्ट करिया पई दैट मीन द राइज टाइम टा को हम कम करू जे राइट जे फास्ट सिस्टम को फास्ट करिया पई हम प्रोपोर्शनल कंट्रोल दे तो जदी हम केपी वैल्यू को बहुत इंक्रीज करि दबा देन सिस्टम टा बहुत फास्ट हेई जिवो आ ओसिलेट करिया स्टार्ट होबो सिस्टम टा हला थि में हमको लिमिट रे इंक्रीज करिया अछि केपी रो वैल्यू सिमिलरली आई कंट्रोलर एक्शन कोन आई कंट्रोलर काम कोन सो सपोज पी कंट्रोलर में एमपी ग्राफ टा पाउछ हला ताले आई कंट्रोलर रे कोन हबो so we can see like this our set temperature is 24 degree Celsius but we are getting less than 24 degree Celsius we are getting a steady value but we are not getting 24 degree Celsius right so this is known as the steady state error this error suppose our output is 22 degree Celsius okay that means we are getting 2 degree less than our set point or our desired temperature so this 2 degree is known as the steady state error the integral control eliminates this steady state error Similarly, derivative control. What is the use of this derivative control? PID पढ़ी सारलनी किसी कोई परनो एक्सपेरिमेंट तो सही PID तो डेरिवेटिव कंट्रोल कौन करियो हमर ओवरशूट को इफेक्ट पकेबो ला जो ओवरशूट रहउची ताको इफेक्ट पकेबो तो देखिए हम एक्सपेरिमेंट कर देखिए आज हमर केमिति आसीबो जो ग्राफ टा प्लॉट करियो हला तो ए ग्राफ रे टेबल बनाओ एक्सपेरिमेंट पई हम कितना कॉलम दरकार चारटा कॉलम दरकार so first la serial number then time then temperature and position driver position is okay or the oven position okay so make 4 columns first one is the serial number then time temperature and position of the this oven switch okay so we have to take the readings in every 5-second interval okay we'll start with 0 second our initial point then 5 then 10 then 15 so each 5-second interval we have to take the readings so up to we will take 30 okay we will take up to how many seconds we have to take up to this 30 readings okay 1 to serial number 30 so 5 and 5 3 15 so 150 up to 150 second we will take the readings so just leave this okay because in every 5-second interval we have to record the reading so we can write it later so you have to write the temperature in every 5 seconds so here this is the timer okay this is the timer and it will show the temperature so in every 5 seconds we have to note the temperature we have to take 30 readings for each this controller R control, P control, PI control and PID controller. We have to take 30 readings for each controller. If we make this hysteresis high, then we have to take at least 50 readings. Okay, and that is why I am not doing this hysteresis mode in high mode. We will do this low hysteresis mode. Okay.
सर हिस्टेरिसिस लो माने कोन हिस्टेरिसिस लॉस मिनिमाइज करिया पई
हमारा जो बीएच कर्व माने अछि लो हिस्टेरिसिस रे कोन हो बीएच कर्व जो विड्थ कम हो हाई रे हाई हिस्टेरिसिस थिबो ताले विड्थ अधिक हो
यस सर
तो जदि हमें हाई नबा ताले हमरो ग्राफ गुडा बहुत लंबा आसीबो माने ए जो ओवरशूट टा से बहुत आसीबो एमटी के एरर टाइ बहुत आसीबो तापे हमको बहुत रीडिंग करबा पड़ियो जदि मेनली हम ऑन ऑफ पाई करबा हम जो ऑसिलेशन हो एमटी ऑन ऑफ रे से ऑसिलेशन बहुत बेसी हो एमटी हो हला तो तापे बहुत रीडिंग नबा पड़ियो प्रति में हम लो रे करिया मैं तेरा रखले क्लियर आछि मैं तुमको तेरा करिया पड़ियो कि मोबाइल ले तो तेरा कर दबो तमे लैपटॉप तेरा करिया पड़ियो ना खाली रीडिंग देखिए
सर मोबाइल लैंडस्केप मोड रे कर दियंतु मोबाइल क्लियर अछि टिके सर पाखु खाली दियंतु
ओके ओके गूगल मैप रे कैमरा शेयर करले क्लियर देखा जाएनी हमारे सेमती आछि गूगल मैप कैमरा शेयर करले से बहुत एटा आछि माने बहुत जଣା पड़िबन ठीक से cannot use file sharing बाकी वाला तो ऑलरेडी देखी देखो ना, खाली अभी रीडिंग टा नोट करियो हल। ये देखा होची मीटर टा, मीटर से तमर काम है। तो समस्ते रीडिंग नोट करियो ना, इच 5 सेकंड रे टेम्परेचर केते रोच। तो समस्ते टेबल बने सारलो, टेबल में चारटा कॉलम बनेबो। सो एटा हम कोन बी आई काटली बुझबानी बिलो। ओके, सो एटा लगा है जी हमरो क्लोज लूप रे ओनली। ओके, ए पॉइंट क्लोज करिया फीडबैक पार्ट क्लोज करा है जे पार्टटा, एंड देन खाली आर कंट्रोल दिया है बेहला। तो बर्तमान देखो हमें एटा मेजर पॉइंट रे अछि, सेट अछि ना, सेट टेम्परेचर करिया पार्ट टेम्परेचर सेट करिया। ये नॉब अछि सेट पई, तो लेट्स मेक इट 60। Okay, so 59.8, so we will assume this 60. Okay, so write down our set temperature is 60 degree Celsius. Clear? Set temperature is 60 degree Celsius. So we will start from 0. Our oven is in cold, in cool position. Okay, so this is off position, then we will on. So this is on off, so we have not connected the this PID control. It is set in low. So now we heat the oven. Okay, this switch will heat the oven, and then we will measure the temperature and turn the time. So note down in each 5 seconds what is the temperature. At 25 degree 42.1, at 30 second 44.7 or 45, 35 48.1. Write on the temperature in each 5 second interval. Now look, the oven switch is off. Okay, the LED is off. It's switched off at 64 degrees Celsius. So you can see now the temperature is decreasing from 68. So we'll take up to 300 seconds, okay, because it's not changing very much. So we'll take up to 300 seconds. Now the oven is on, right? You can see the LED is glowing. Now it is off again. One. बहुत कष्ट सर लेवल पूर्ण करें बहुत कष्ट is happening. So all of you are taking a reading, right? Note down the reading. Now the oven LED is glowing. That means it is being heated. So we'll stop, right? We'll stop this on-off controller. It is already been 3:15, already 3:20 seconds. So we'll stop this experiment, this one. So we'll plot this one, okay? So we can see that, right? This the temperature is fluctuating. Our set temperature was almost 61. So if we draw on this curve, it will be like sharing. So next we will do this P control. Okay, so I will change this curve to this P control. You can add here also. So let's connect this in the same place. So now note down the value of P. The Kp is Kp is 4, okay, 0.4. Note down the value of Kp is 0.4. So now I have given this connection to this P control, right? You can see the connection is switched from R to P control. So now again we do this one. So our set temperature is 60.7, or you can write 61. Okay. So let's first cool down the oven. Bring it down to the room temperature. So this is forced cooling. I am doing that. If I only do off, then it will take time. So we have to wait until it's come to about this 30 degree. तो समझते रीडिंग लिखिल ना लिखिन The temperature is now 44. Okay, we will wait until it's go beyond 35. It will, I think, take 20 to 30 seconds. Okay, we will assume that this is our room temperature, 33 degrees Celsius. Then we will start this proportional controller. Okay, so let's check the what is our set temperature again. So it is 60.6. Let's assume this is your 60. Okay, the set temperature is 60. It will take time to exactly set the temperature 60. Okay, so let's say our set temperature is 60. That means
Sir, now it is with Kp.
huh?
Sir, now it is with Kp equal to 0.4.
Yes, the value of Kp is 0.4. We are doing with proportional controller only. Okay, only the proportional controller with Kp value 0.4. So then we have to heat the oven, then measure the temperature and add the time. The same after each 5 second interval. So let's take 10 second interval. Okay, in 10 second interval, note down the temperature. 10 second interval. In every 10 second interval, note down the reading. We will go to 300 seconds. Now look at this LED bulb. Okay, as the oven is being heated, it is glowing. When it will be automatically off. When it will be automatically off. Okay. up to 300 seconds. Okay, we'll take the reading. So next we'll switch to PI controller. Okay, so let me first pull down this. I am resetting the time. Right now 0 because we will start with 0 time.
सर एटा का ପାଇଁ
ଏବେ ଷ୍ଟାର୍ଟ କରିବା ଆମେ PI କଣ୍ଟ୍ରୋଲର ପାଇଁ ହେଲା। ଏଇଟା ଥିଲା P କଣ୍ଟ୍ରୋଲର ପାଇଁ,
ଆଜ୍ଞା ସर
ଏବେ କରିବା PI। ସୋ I ଏଥିରେ ମୁଁ ଆଉ ଗୋଟେ ଫଙ୍କସନ୍ କରିବି ହେଲା, କହିଦେବି PI ଆଇବ। टेम्परेचर रूम टेम्परेचर को पड़े आस स्टार्ट करिए। तो each 10 सेकंड इंटरवल रीडिंग हम तार आउटपुट ग्राफटा ड्रॉ करिए टेम्परेचर वर्सेस टाइम, एक्स एक्सिस रे टाइम, वाई रे टेम्परेचर। कौन पाइल से ग्राफ रु कौन ऑब्जर्व कल सेटा तुम कंक्लूजन रे लिखियो। जेंति ऑन ऑफ कंट्रोलर रे हमर ओसिलेट होबो हला, जे सेट पॉइंट सेट टेम्परेचर अराउंड रे ओसिलेट होबो, किंतु पी कंट्रोलर रे हमर टिके ओवरशूट आसीबो, किंतु तापरे टेम्परेचर टा ऑलमोस्ट कांस्टेंट रहिबो हला। जेंति 57 पॉइंट केतरे ऑलमोस्ट कांस्टेंट ला टेम्परेचर टा, किंतु स्टेडी स्टेट रहउची काइना 59 हमर थिला सेट पॉइंट, किंतु हमें पाउचे 57 डिग्री सेल्सियस टेम्परेचर। सो 2 डिग्री रो स्टेडी स्टेट रो आसचेला सेउरा देखिबो कंक्लूजन। तापर लेख पी हला 0. जेपी 0.4 एंड केआई 0.5 वैल्यू हला। जेपी वैल्यू 0.4 एंड केआई वैल्यू 0.5। रूम टेम्परेचर पळे आसिला, रीडिंग नबा हिट करिया ओभनटा, heat position, measure, and then run. Okay. So in each 10 second interval, take down the.
नहीं जैसे 10 seconds पर चढ़ती है।
10 second नहीं है। एलईडी देखो दिबो एतल टेम्परेचर बढ़ु थिबो सेतेबेले एलईडी जळिबो, टेम्परेचर कमिबा स्टार्ट होबो सेतेबेले एलईडी ऑफ हे जिवो। तामे जब टेम्परेचर कमुची माने ओभनटा हीट होगी।
जो टाइम ऑफ होची से टाइम से रीडिंग में लेके से टाइम
सेटा लिखिए पोजीशन ऑन ऑफ।
जो टाइम
रे ऑफ होची मार्क करथिबो लाइट टेम्परेचर रे ओभनटा एलईडी ऑफ हेची, पुनी आउट जेटा ऑन होबो से टेम्परेचर का आउट मार्क कर रखे ए टाइम रे ऑन हेची ओभनटा हला। अच्छा जे पोजीशन अछि जो फोर्थ कॉलम टा तेते लिखिबो जेतेबेले तमरो ओभनटा ऑन थिला ऑफ थिला को टेम्परेचर रे। एटा भी 300 सेकंड जे नबा। 300 second complete, right? So what did we observe here that the final temperature is always around 59, right? Our set temperature 59 point something, and our final temperature was always around this 59, nearly 59. So you can see now it is 59. So that means the steady state error present during the only the proportional controller is now eliminated by the use of integral controller. Okay, so you have to write that in your conclusion, that the steady state error is eliminated. So now we will do the PID control. So we have completed three controller: the on-off or relay control, then the proportional controller, and then the PI controller, and now we'll go to the PID controller. So I will add another wire here, right, from D. So I will add from this D to here. So now we can see we have all this PID control, but we are not connected this relay control. Okay, only the PID control, and this is the feedback part. Okay, so let's come down to the room temperature, and then we will take the reading.
सर क्रेटेड है कितना
KD was 0.2. The same value KP is 0.4, KI is 0.5, and KD is 0.2. The set temperature is 59. Right. 59.3. So let's take it 59. Okay. So let's increase the some set temperature here and see. So let's say 65. Okay. Now I have changed my set temperature to 65. Okay. So 65, around 65. So now it is in a room temperature. Now we have to heat the oven, measure, and now run the timer. So same in 10-second interval. Note down the reading up to 300 seconds. So 300 second पार हो ना समझते लिखिए तो रीडिंग गुड़ा तो तुमको सब प्लॉट करियर अच्छे एटा टाइम विथ टेम्परेचर ओके तो टोटल 4टा ग्राफ हो
सर केडी केते नि आइतला
केडी 0.2 हमरो ग्राफ गुड़ा ताले केमती आसीबो समस्त क्लियर तो पॉइंट गुड़ा नै कि ग्राफ गुड़ा ड्रा करियो हला so जदि हम ड्रा करिबा सेट टेम्परेचर स्टार्टिंग हमर केते थिला अराउंड 60 राइट 59 so स्ट्रेट लाइन टाणीबो 59 डिग्री रागो लिखि जावा सेट टेम्परेचर ता रेफरेंस टेम्परेचर तो ऑन अप पई ग्राफ टा 33 ରୁ स्टार्ट ହେଇଛି तो ग्राफ टा केमती आसीबो एमती टिके ओसिलेट हो ग्राफ टा हला देखियो त पॉइंट नै की फॉर डिफरेंट टाइम केमती आछि सेमते दि पी कंट्रोल पई करबा सेट टेम्परेचर लिखियो हला पी कंट्रोल पई हला आर रिले कंट्रोल सिमिलरली जदि हम पीआई करबा सेट टेम्परेचर 59 थिला तो पीआई टा ओके पीआई टा एमती आसीला ए जो स्टेडी स्टेट एरर बहुत कम आसीबो पीआई केस रे तो देखियो तुम ग्राफ रे डिफरेंट लेवल 59 है ना सेट टेम्परेचर 59 डिग्री सेट टेम्परेचर स्ट्रेट लाइन टाइम लगा तो सही अराउंड रे हमर वेव फॉर्म टा वेरी करिवो पीआईडी दबा ताहले सेमति पीआईडी पई करिवो तो पीआईडी पई थिला हमर केते 65 डिग्री सेट टेम्परेचर राइट तो 65 डिग्री रे स्ट्रेट लाइन टाणीवो आ ग्राफ टा ड्रा करियो तो ग्राफ टा मे भी एमती आसी पारे हला देखिवो पीआईडी पाई तो प्लॉट करिवो 300 रेटिंग 30 टा रीडिंग नै छ 10 10 सेकंड इंटरवल रे तो फिर टाइम नबो आ एक्सरे टेम्परेचर ओके तो ये बळे ग्राफ गुडा आसीबो समस्ते ग्राफ पेपर रे ग्राफ ड्रा करिवो हम पठे दे मैनुअल टा कोन दरकार कोन नै देखिया पे थ्योरी आ हमर जो ग्राफ गुडा केमती आसीबो अच्छी कहियार अछि एक्सपेरिमेंट ऊपर So experiment କାହାର କିଛି ଡାଉଟ୍ ଅଛି ଯଦି କୁହ। ସମସ୍ତେ ଲ୍ୟାବ୍ ରେକର୍ଡ ଲେଖିବା ଷ୍ଟାର୍ଟ କର ହେଲା, କାହିଁକିନା ତମକୁ ସବମିଟ୍ କରିବାକୁ ପଡ଼ିବ। ତମର 6th ଏକ୍ସପେରିମେଣ୍ଟ ସରିଲା ଆଜି।
ସାର୍ ଟିକେ ମାନେ ପୂର୍ବ ଲ୍ୟାବ୍ ଗୁଡ଼ାରେ ଟିକେ ମାନୁଆଲଟା ଟିକେ ଦେଇପାରିବେ।
ପୂର୍ବ ଲ୍ୟାବ୍ରେ କ'ଣଟା?
ମାନୁଆଲ
ତମମାନଙ୍କୁ ସବୁ ଜିନିଷରେ ମ୍ୟାନୁଆଲ କ'ଣ ପାଇଁ ଦରକାର ମୁଁ ବୁଝିପାରେନି। ତମର ମନେକର ଯେ ଏକ୍ସପେରିମେଣ୍ଟ ଥିଲା କ'ଣ ଥିଲା ଫାର୍ଷ୍ଟଟା ଷ୍ଟେପ୍ ରେସ୍ପନ୍ସ ଅଫ୍ given plan ଥିଲା ନା, ସେ ତମକୁ ମ୍ୟାନୁଆଲ କ'ଣ ଦରକାର ମୁଁ ବୁଝିପାରୁନି। ଷ୍ଟେପ୍ ରେସ୍ପନ୍ସ ଥିଓରି କ୍ଲାସରେ ପଢ଼ା ହେଇଛି, ଥିଓରି ଲେଖିପାରିବ। ଏମ୍ ଅଫ୍ ଦ ଏକ୍ସପେରିମେଣ୍ଟ ଷ୍ଟେପ୍ ରେସ୍ପନ୍ସ ଅଫ୍ ଏ ଗିଭେନ୍ ପ୍ଲାନ୍। ତାପରେ ତମର ଏପାର୍ଟ ରିକ୍ୱାର୍ଡ କ'ଣ ତମେ ଲେଖିବ ମ୍ୟାଟଲେବ୍, ମ୍ୟାଟଲେବ୍ ହେଇଛି ମ୍ୟାଟଲେବ୍ ଲେଖିବ, କିଛି ଲେଖିବା ଦରକାର ନାହିଁ। ତାପରେ ତମର ଯୋଉ ଅଛି ଥିଓରି ଷ୍ଟେପ୍ ରେସ୍ପନ୍ସ ତମେ ଲେଖିପାରିବନି ଗିଭେନ୍ ପ୍ଲାନ୍ ପାଇଁ, ଫାଷ୍ଟ ସିଷ୍ଟମ୍ ପାଇଁ ଥିଓରି ଲେଖିପାରିବନି। ତାପରେ ତମର ପ୍ରୋସିଜର ଲେଖିବ ତମେ କ'ଣ କଲ, ମ୍ୟାଟଲେବ୍ରେ କ'ଣ କରାହେଇଛି, କେମିତି ତମେ ଷ୍ଟେପ୍ ରେସ୍ପନ୍ସ ବାହାର କରିଥିଲ, ଆଉ ଆଉଟପୁଟ୍ ଗ୍ରାଫ୍ ଗୁଡ଼ା ତମକୁ ପଠା ହେଇଛି, ତ ସେ ଗ୍ରାଫ୍ ଗୁଡ଼ା ଡ୍ର କରିବ ସେଥିରେ, ତାର କନକ୍ଲୁଜନ ଲେଖିବ। କନକ୍ଲୁଜନ ତମେ ତ ଲେଖିବ ନା, ତମ କାମ ନା, ସେଟା ବି ଲେଖିଦେବ। ଏତେ କ୍ରିଏଟିଭ ହୁଅ ପିଲା ଗୋଟେ, କ'ଣ ତମେ ସବୁରେ ଆମକୁ ଦିଅ ଆମେ ସବୁ ଉତାରିବୁ, ଖାଲି ଆମେ ରିଡ଼ିଂଟା ଲେଖିବୁ। ସିଷ୍ଟମ୍ ଆଇଡେଣ୍ଟିଫିକେସନ ତମକୁ ପଠେଇଛି ସବୁ, କ୍ଲାସରୁମ୍ରେ ଅପଲୋଡ଼ କରାଯାଇଥିଲା। ଷ୍ଟେପ୍ ରେସ୍ପନ୍ସର ବି ପ୍ରୋଗ୍ରାମିଂ ଆଉ ତାର ଆଉଟପୁଟ୍ ଗୁଡ଼ା ଅପଲୋଡ଼ କରିଛି। ପ୍ରୋଜେକ୍ଟ କାମ କେମିତି କରିବ ତାହେଲେ ଫାଇନାଲ ଇୟରରେ, କିଛି ଦିନ ପରେ ଫାଇନାଲ ହେଇଯିବ, ରିପୋର୍ଟ କେମିତି ଲେଖିବ? ଟ୍ରାଏ କର ହେଲା, କିଛି ପ୍ରୋବ୍ଲେମ୍ ହେଲେ କହିବ, ତମେ ଖାଲି ସବୁ ଆମକୁ ଦିଅ ଆମେ କରିବୁ କହିଲେ ତ ହବନି ନା। ଯଦି ଆଉ କାହାର କିଛି ଡାଉଟ୍ ନାହିଁ ରିଗାର୍ଡିଂ ଏକ୍ସପେରିମେଣ୍ଟ, ତାହେଲେ ବନ୍ଦ କରିବା ଏଇଠି।